So we have one end of a string is attached to a small ball P of mass 4m. So the weight of that ball will then be 4mg. The other end of the string is attached to another ball, mass 3m, so the weight there would be 3mg. I'm going to draw the tensions as well, so T and T. We're told the string passes over the pulley, ball P is held at rest with the string taut and hanging parts of the string vertical, so that's all usual stuff. Ball P is then released. And then we have our modelling assumptions. The string is light and inextensible, the balls are modelled as particles, the pulley is modelled as being smooth, and the air resistance is ignored. Okay, so use the model, find in terms of m and g the magnitude of the force exerted on the pulley by the string while P is falling and before Q hits the pulley. So the tension throughout the string is the same everywhere. And that's because the string is light, so it has no weight, and also because the pulley has no friction. If those two things are true, tension is the same everywhere. So therefore on the pulley, this part of the string pulls the pulley down with a force of T, and this part of the string, here, pulls the pulley down with a force also of T. So therefore for part A, the overall force on the pulley would be 2T, so then our goal is just to work out what T is. And then it's a standard kind of question. So we know that the 4m mass is heavier, so the acceleration will be downwards for 4m, for P. And for Q, the acceleration will be upwards. We form our two equations of motion. So for P, it will be 4mg minus T, that's the resultant downwards force, is equal to ma, its mass times acceleration. And similarly for Q, the acceleration is upwards, so T minus 3mg would be the overall upwards force. That's the resultant upwards force. And that's equal to ma for this object. So 3m is the mass, times it by a. And then add the two equations. The t's cancel. The 4mg minus the 3mg would become 1mg. The right-hand side becomes 7ma. A's cancel. And then a is then g over 7. So then we can put that into our equation, one of these two equations, to work out what T is. So I'll put it into the second one. If I rearrange that, T is equal to 3ma plus 3mg. So this is the second equation rearranged. I'll put in A as g over 7, so we get 3mg over 7 plus 3mg. 3 over 7 plus 3 would be 24 over 7 mg. And then the answer is 2t, so we just times this by 2. So our answer, the force on the pulley, would then just be 48 over 7 mg. The tension just multiplied by 2. And for part B, state one limitation of the model, apart from ignoring air resistance, that will affect the accuracy of your answer to part A. So we just look at our modeling assumptions and say one of those things wouldn't be true. So we can say the string would not be light.